Suntem live.
Începem, da? Bun. Pentru că suntem live deja, spun în primul rând bună seara tuturor celor care sunt live acum aici. Mă bucur foarte mult să ne vedem sau să ne revedem, cine știe. Discuția din această seară va fi o discuție extrem de interesantă, vă garantez, pentru că vom vorbi despre cartea pe care o vedeți deja pe ecran, Călătorie spre centrul Pământului, extraordinara expediție de explorare științifică în adâncurile lumii noastre. David Whitehouse este autorul acestei cărți. David Whitehouse este, în primul rând, cercetător, este doctor în astrofizică, dar a fost și jurnalist BBC, jurnalist de știință, este scriitor. O să vorbim cu el așadar despre această carte, dar și despre alte cărți ale sale. Dialogul va fi în limba engleză. Așteptăm să ne scrieți, să ne puneți întrebări, să le trimiteți pe chat. Suntem live pe Facebook-ul Bucharest Science Festival, pe Facebook-ul Humanitas, în primul rând, gazda acestei discuții. Mulțumesc foarte mult Editurii Humanitas, pe Facebook-ul Radio România Cultural, pe Facebook-ul lui Cristian Presură și așa mai departe. Iar acum o să switch to English, to David Whitehouse. Welcome, David Whitehouse. Thank you very much for being with us.
Thank you for asking me.
We are very thrilled that we will have the chance to talk about a journey to the center of the Earth. So nobody was there. We don't know how it is there. Apparently, you know how it's there.
Well, it was a fascinating book to write because I'd written several other books, and I was looking around for a new topic. And you know, writers look at anniversaries and they look at events coming up, and they try and find some idea of writing a book that perhaps nobody else has written. And I noticed that it was the 150th anniversary of Jules Vernes writing about Journey to the Center of the Earth, that famous novel he wrote. And I thought, well, actually, why don't I take that anniversary and do a scientific version of that journey to the center of the Earth, but also reference the book? Because Jules Vernes' books is a fascinating book for many reasons, and I could incorporate that into my book. So yes, it's a scientific journey from the crust of the Earth right down to the core, with a diversion into the magnetosphere, which is the Earth's magnetic field, which is generated within our planet. And I must admit, it was a journey that was far stranger than I'd ever expected it to be.
Why?
Well, our planet is divided into two sections. You have the outer rocky section. You've got a thin crust at the top. Then underneath you have the mantle, which is a much thicker. Most of the Earth is mantle. And this is, well, basically rock, although it's under a great deal of pressure and it moves. And inside that rock, which you come onto, there are all sorts of movements and structures. But inside the center of this rocky exterior, the center of our planet is made of metal. We have an outer core, which is made of liquid iron, plus some other constituents, and an inner core, a solid inner core, which is made of solid iron. The inner core is roughly the size of the moon. So we are two planets. We've got, inside us, we've got this rocky outer shell. We've got the ocean of liquid iron beneath that. And then we've got this solid planet, if you like, right at the center of our world, which, to my amazement, hasn't been there since the Earth was formed. It's new. and it's growing. And so I tried to do a journey from the crust, which obviously we live on the surface of the crust, and it moves around in terms of tectonic plates that move around with each other. And you get volcanoes and earthquakes due to the deformation of the brittle crust on the surface. But then when you go down and it gets warmer, things move in a much more plastic way. And there are structures there moving which take tens or hundreds of millions of years to move from the bottom to the top. But then, as I said, when I got to the liquid core, I was absolutely astounded that the planet there is totally different from the rocky world that we experience nearer the surface. So it was a journey for me, and I hope readers can follow this journey as you go from the top. I mean, I went down mines, which I thought, because one thing as a writer, it's nice to do, is you don't just put the information up on the page. You actually go to significant places and you experience them, and you write about your experience. And I remember going down one of the deepest mines in Europe and getting right to the bottom. And then I crouched and I put my hand on the floor, very dusty, very hot. And I realized there was then, nothing between me and this, and the center of the earth, and this central ocean of liquid iron.
You are talking about the Bowlby mine, yes, in Cleveland.
Yeah, the Bowlby crater. It's 3,000 feet, 1,000 meters deep. Now that's a tiny fraction of the radius of the Earth, and yet when you go down to even that small amount, it's a different world. It's a world of heat. It's a world of pressure. It's a dark, quiet world, and I was fascinated by the way the rock and the material, as you go nearer the center of the Earth, how the pressure changes the rock, and how we can try and reproduce that in the laboratory to do experiments. I must admit, coming from a place where I'd always regarded the Earth as a platform to observe the rest of the universe, to actually look at the Earth as a planet and realize the wonderful structure was a great eye-opener for me.
We have to tell the listeners who have not yet seen the book. So this is a very nice book with a lot of pictures, and I would like you to maybe to comment a little bit some of them, because they are some of them are historically, yes, they have a historical importance. Also, we have to tell the listeners that you also wrote The Moon, a biography, The Sun, a biography. Well, now it's time for a biography of the Earth we are living on. But you also say that this, this journey into to reach the core of the Earth is most probably will never take place.
No.
Are you sure?
Well, I suppose you should never say never in science, but the conditions and the pressures and the temperatures are so extreme. We probably will never do this. I mean, we can't, if you these things are thousands of miles beneath our feet. 4,000 miles beneath our feet is the center of the Earth. And we have only drilled a mile or so into the surface. And when you get to the bottom of, in terms of people going down mines, it's only about a mile or so, although we've drilled holes a little bit further than that. The temperatures down there are so extreme that you cannot drill a hole because it sort of wants to fill itself up again. And you end up with a drill that's so long, it's unwieldy. There was a fascinating section of the book where I wanted to ask, because when you write a book like this, you can structure it around some questions. And I wanted, one of the questions was, what is the deepest hole we've ever drilled? And it turns out that it's in northern Russia. not far from Sweden. And it's an amazing project. The deepest hole ever drilled, the Kola super deep hole, in a very inhospitable place where the crust of the earth is relatively thin. And it sent back, we got some wonderful samples, but ultimately they could not drill much further than about 10,000 meters because it was just impossible technically. And I can't see us getting much deeper than that in the future.
You are talking about the that drill in Kola?
That's right.
Yeah?
Near Murmansk.
Near Murmansk, yes, it's 12,262 meters. So that's the deepest point, sorry, they reached in 1989, actually.
Right.
But how far it is from the center, do we know?
Well, the Earth is about 8,000 miles across. So the center is 4,000 miles or so beneath our feet. And this got 7 miles deep. So you see, it's a tiny fraction, tiny fraction we will never, I mean, you see science fiction films sometimes of being able to descend to the core of the Earth. And the pressures, the temperatures are so great that we're never going to do that. In the future, the Earth will break up when it dies. And the core will explode because it's under such pressure at the moment. But whether or not, we will be around to see that in billions of years' time remains to be seen.
Yes, fortunately or unfortunately, it depends on the perspective you are taking to look at this.
Right.
But how do you know? Can you be so sure that? How can you be so sure that the Earth will explode?
Well, I had great fun writing about the death of the Earth. I mean, you're quite right. This book, although it's called Journey to the Center of the Earth, has got a bit of an element of a biography. And it was, I think, natural to write about the Earth in this way after I'd written the Moon and the Sun biography books. And of course, I deal with the end of the Earth. Now, if you look at the structure of the Earth at the moment, it's got a very strong outer layer. It's very tight. It holds, it's very compressed. Inside is under great tension. And the thousands of miles, the thickness of the mantle is so good as an insulator that the temperature at the center of the Earth has hardly changed at all since the Earth was formed. It's cooled down very little. But when the sun changes, and in 4 billion years' time it becomes a red giant, it will swallow the Earth up. It will become so big that the Earth's orbit will be robbed of its energy, and the Earth will then fall into this bloated sun. And what will have great fun with this, I had this, I tried to describe this, and what will happen is that the outer tectonic plates will fracture, and they will buckle, and then the pressure underneath will cause them to explode. In the future, actually, there won't be so much of a liquid outer core, liquid iron outer core as there is now, because the most amazing thing I found about the Earth is that the inner core, the solid iron inner core, is growing. And it will have grown in a few billion years' time. So there won't be much liquid down there. But the outer range will fracture, will explode and fragment. And then there'll be, as the Earth is drawn into the sun, it'll start to crumble. And the rocks will turn into dust and trail behind the orbit, rather like a comet's material trails behind a comet these days. But the last thing to die and be smeared out will be the iron core of the Earth, the iron metallic heart. And that will be a sliver of silver. And then the Earth will be gone. So the only time we're ever going to see the core is if we're ever present when the Earth dies. It's amazing that it's only the distance from, say, where you are to India, or it's that type of distance underneath our feet, and yet it's a journey we can never take because the conditions are so extreme. When you fly across the Atlantic, you're traveling roughly the distance between the surface and the center of the Earth. But as I say, we can never do this journey.
Like you were written on this book, it will be possible to to find out more about galaxies and stars and whatever worlds far away from here, but we'll never be able to understand and to really touch the core of the Earth.
That's
but
right.
For the sake of this discussion, let's let's use our imagination. So let's try to imagine that we are going now down to the core of the Earth. What are we seeing? We are starting from the surface, and we are going through how many layers? Why are so interesting these places? What do you learn from these places?
Well, starting off at the surface, it depends upon if you go down from a continent or from the ocean, because the continents are very old islands of rock which seem to float around and move around the surface. They are the oldest rocks we know. One of the questions I tried to answer in this book is, where is the oldest rocks you can find? Which part of the world can you go and stand on the oldest rocks? And that turns out to be Canada. If you start off with these very old rocks and then you go down into the earth, the temperature, of course, gets much hotter. The pressures get higher. The thin skin of the earth is divided into plates which move, and some of these, and you could argue, you could see that the mantle of the earth is not fixed. When I was at school, we were told that the thick band of the earth, the mantle underneath the surface rocks, doesn't move. We now know it does. It's plastic. And you get currents moving up, taking millions, perhaps billions of years, and they move up and they appear in the central ocean ridges, which is where new land is formed. And these ocean ridges spread out. And as they move, they push the tectonic plates around and move the continents around. In fact, it's strange at the surface, the continents are billions of years old, and yet no part of the ocean floor is older than 200 million. It's new stuff. So you have this active outer region where there are moving tectonic plates, where there are volcanoes, where the tectonic plates do interesting things. There are earthquakes. But as you go further in, the rock stops being brittle and it comes under a great deal of pressure, and it changes. It gets compressed and it changes its structure and its properties. And one question for a science quiz is, what is the most common material on Earth? And actually the answer to that is perovskite, is the type of rock beneath our feet. So most of the Earth is made of perovskite. And as you go down and down again, you find that there are structures in the mantle. There are plumes which move up and down. And there's one fascinating scientist I spoke to who said that in Earth's history, there are times when these huge plumes of hot material rise up to the surface and cover vast areas with molten rock. And there's one at the moment, we can see past evidence of this, and it changed the Earth's climate quite dramatically. And there's one that's coming up actually, but unfortunately, it won't be here for another 200 million years. But if we're still around, then we would have to deal with this change of the Earth's surface. But the mantle is a much more active place, and I was fascinated to see that there are structures in the mantle which are almost like new continents. And we don't know a great deal about them, but we can detect them from the way they affect the movement of shock waves and sound waves from earthquakes.
So we can, we can learn a lot from seismology.
Oh, the most we learn about inside the Earth from basically in two ways. Most of it is from earthquakes, from seismology. And the story of seismology is absolutely fascinating. I mean, there was a lady I came across called Inge Lerman, who's Dane. And she didn't die till about 1993, 1994. And had I realized, I would have made an effort to meet her. I was obviously around at that time, but I didn't realize. She was the person who studied earthquakes, the vibrations of the ground at various places on the earth. And she worked out that there was a solid center of the earth. You went down, you had the mantle, you had the liquid outer core. But she found out that there are sometimes the shock waves that ripple through the earth are disturbed by something at the very center. And she discovered the iron core of the earth, the inner core. And she only died fairly recently. This is a new thing. So the mantle, as I said, is just a wonderful active place. The more we look at the mantle, the more active and important it seems to be as influencing the earth. For instance, there's some idea that the volume of water in the oceans might be related to the cycle of rocks being formed, coming up to the surface and going back into the earth. And the constituents of our atmosphere might be affected by that as well. So this outer layer, as I said, there are two planets here. This outer layer is very active indeed. And then, of course, you get to one of the most fascinating regions, which is the boundary between the mantle and the outer core. You have rock, plastic, hot rock on one hand, and then you have this liquid iron. And it seems that the boundary, the core mantle boundary, could in places only be a few meters or a few tens of meters across. And yet the fundamental nature of our planet changes in that region. And when you get down to the liquid iron, it's an ocean of liquid iron. It's hot, but you could swim around in it. It's not very viscous. And there are currents and movements, eddies, and it's in that region where you've got electric currents moving that generates the Earth's magnetic field. And that magnetic field stretches from the outer core way out into space and actually protects us from radiation. So if we did not have a liquid outer core beneath our feet, the Earth's surface would be unprotected and uninhabitable. So that's why I call us, in I think some parts of the book, we are children of the core.
Mm-hmm.
We are not just here because of the sunlight and the rain and the seasons and the temperature and all that. That's not enough to keep us alive. We're actually alive because the way down beneath our feet, thousands of miles down there's a dynamo which generates an a magnetic field which protects us. So we're as much here because of what's happening down near the center of the Earth as we are, because of the sunshine and because of the water.
It's very interesting. You also have a picture in the book. I will show it here.
Yes.
This is an experiment that is taking place at the University of Maryland. Yes?
Yeah. This is a wonderful experiment. I say there are several ways we can find out about what's going on down there. We can look from earthquakes, or the information we get from earthquakes. We can do experiments. You can reproduce the pressure. But that experiments and see how that affects the materials, how it affects rocks. But that experiment at Maryland is amazing because basically it's a huge sphere of molten iron. And they are spinning it to try and understand how the currents and how the outer core of the Earth behaves, and try and work out some ideas about the magnetic field of the Earth. And that's an amazing experiment to see that in operation. It's a simulation of the core, of the outer core of the Earth. Wow, yeah.
It's a simulation, but they can they simulate all the how to say conditions?
No, it actually you're doing bits and pieces in the sense. Of course, you haven't got the scale. It's a very small scale experiment, but you can play around with the constituencies. Not just liquid, not just molten iron. There are sulfur and various other elements there, which do seem to have an effect. So you're teasing out the parameters slowly by which the outer core works. And you can observe the outer core by measuring the magnetic field of the Earth at the surface. In fact, one of the reason why the magnetic pole moves around is because the currents in the outer core which generate it are unstable. And therefore the Earth's magnetic pole moves around from time to time. And amazingly enough, from time to time, the Earth's magnetic field collapses and then re-emerges with the north and south poles reversed, a geomagnetic reversal. And these seem to happen at random, and they have some effects of life on the surface. And of course, we would like to be able to predict those. But the Earth's magnetic field is an amazing structure. It's generated thousands of miles beneath our feet, but we can measure its changes and we can work out the currents and the streams and the drifts of the magnetic molten iron in the outer core, which I say is I almost imagined, you could be, if you could possibly build a craft to move through it. Of course, you have temperature and pressure there, but yes. It actually is like water. It's the viscosity of water. You could move around. If you were protected in a spacesuit, so to speak, you could wave your hands around and go swimming. It's not solid stuff. It's very viscous, and it's just an amazingly different place. And of course, then when you move through these currents, you come to this moon-sized object right at the very heart of our Earth, which is a solid core of iron. And that is the most amazing structure. It's dense. It seems to have valleys, small valleys and plates on its surface. But the most amazing thing I found out about that is that it's new, in the sense that up till about 500 million years ago, the interior of the Earth was all liquid. It was all liquid. But round about 500 million years ago, the time at which complex life started to begin on Earth, there was this, I write about it as a tiny crystal. It got sufficiently cool at the center that out of this liquid iron, there was one crystal formed, and then another. And slowly it was the size of a ball and then a grapefruit, and it got larger. And that's what it's doing at the moment. For 500 million years, this iron crystal, giant iron crystal at the center of the Earth, is getting bigger and bigger and bigger. And it will continue to do so in the future.
This is fascinating. Anyway, you are writing in your book that the Earth recovered quite, quickly after the transformations. Yes, that he passed away. So can we think that the Earth is still transforming, is still adapting to,
yes,
into what?
The Earth is definitely changing for several reasons, on several timescales. On the surface, the continents move around, and there are times when the continents are in one large region, a supercontinent, and then they break up, and at the moment they break up and spread around the globe. But they will eventually come back together again, and the huge continent that's at the South Pole, Antarctica, will move north and the ice will melt. And when that happens and all the land masses come together again for a while before they then break up again, that will affect the climate of the Earth quite dramatically. It will affect evolution in the past. There are times when the dinosaurs, for instance, ruled the Earth. There was a supercontinent, so the dinosaurs were able to move vast distances. And then when the continents broke up, that carried the dinosaurs with them, and then isolated individual continents like Australasia, so that their evolution was different and produced different animals from those in Eurasia. So the changes on the surface, certainly. There are changes in the mantle as these hot structures come up to the surface in a few 100 million years' time and produce a volcanic eruption, the like of which we've never seen before.
Mm-hmm.
And then, of course, there's the core, which we just mentioned, which is ever getting bigger. And there'll come a time in the future, it won't be the sun getting large that destroys life on Earth, that means we can no longer live here. It actually, the death of the Earth will come about from within, because this iron core will get sufficiently large that the liquid outer core
It will expand.
will be used up.
Mm-hmm.
There won't be much there. And the Earth will stop being able to generate this protective magnetic field. And then we will be subject, if anything living on the surface will be subject to harsh radiation. And the surface could not support life. It's as we just said, if the Earth's magnetic field was to switch off to zero tomorrow, everybody would be dead in a year.
Mm.
Yeah.
This is a very sad, picture of self-destruction, to say.
But you could say, yes, that's so. Right. We are, but then again, we are entwined with the Earth.
Yes.
We are a part of the Earth.
That's true.
And therefore we take part in the Earth's changes. It shaped us. And I think we're clever enough, these are billions of years in the future. If we survive and if we change, we are clever enough to cope with this. But what you imply is quite right. There will come a time, if we live long enough as a species, that we will have to leave the Earth and go and find somewhere else to live.
And this we reach, your main field, yes, space. So how come that you, gave up looking at space and now you are focusing on the inner of the Earth? And how much helped you to understand these things having this background? Well,
when I stopped being, I was originally an astronomer.
Yes.
At local bank, a radio astronomer. And then I moved into space physics. And then the BBC offered me a job as a science correspondent. And I did that and thoroughly enjoyed it. But but one of the things I most enjoyed doing when I was at the BBC was writing my book about the Moon, a biography. And I wanted to do more of that. So I wrote about the Moon, a biography, which was a fascinating thing to do. I've always been fascinated by the Moon. And I realized that you could hardly buy a book where everything was in one book: the history, the mythology, the effect on our behavior, the future, the exploration, the astronauts. I tried to put that all in one book. And then when I'd done that, I realized that as I was researching the mythology of the Moon, I was coming across its relationship to the sun. Mm-hmm. And so I thought, well, I'm going to have to write a book called The Sun, a biography. And that was great fun to write. And then somebody asked me to write a biography about Galileo. Now, as a writer, normally you come up with the ideas yourself. And that's quite tricky. We'll perhaps mention a few about how you come up with ideas. But when somebody comes along and says, will you write a book about Galileo for the anniversary of the invention of the telescope? And they give you some money. It's a strong-willed writer that says, no, thank you very much. So I wrote a biography of Galileo. Then I wrote a book about astronauts. But after that, I was thinking, well, I don't really want to write about planets, about astronomy. I want to write about other things. And it struck me that while I was thinking of doing that, changing the focus a little bit, looking in instead of out, was a nice way to expand as a writer, write something differently in a new type of way, talk to a different subset of people that I'd never spoken to before, and think about how I would tell the story of the Earth and the journey from the crust to the core. So that struck me as being a different thing to do, because the thing as a writer, you don't want to write another book which is just like the one you've just written. You want to actually, write something different, because if you didn't write something that was a bit different, you'd go mad. And unfortunately, the 3 or 4 books I've written since Journey to the Centre of the Earth, in various stages of preparation, have all been different, and deliberately so. So Journey to the Centre of the Earth was a different type of book, but I needed to write it because I wanted to write about the science of the Earth and looking in rather than looking out. I mean, subsequently, I wrote a book about Apollo 11 landing on the moon.
Yeah. One small step, the inside story of space exploration.
That's right, which was a very different type of book. That was a very different type of book from anything I'd written before, in the sense that I let it stay in the voices of the people who did it, because to digress into that book, in the sense that I realized that when people write about astronauts, frequently many books I'd read had sort of a quote or two from the astronaut or the administrator or the politician, and then you had a couple of paragraphs from the writer saying what they meant and what they were doing. But I thought, no, this is such an exciting story, and the people tell us about it and they're still around. I'll have a not so much from me, and I'll keep it in their words. So I selected a thread of quotes that followed sequentially to tell the story, and I tried to let them tell it in their own way. And so it was much more like a film than it was like a book. And I was a bit worried, would people get it? But fortunately, people did. And I got lots of good comments for that book, in the sense that you feel as though you are there and people are telling you what happened. And there's some very dramatic bits in that book. So, each book, as a science writer, you try to find something to write about, which is not easy these days, because there are so many science books around and there are lots of clever people coming up with ideas.
Yeah.
But then you try and write it in an interesting way, because there's just one comment, that there's a saying in writing that if people don't want to read your book, nothing will stop them. You've got to write a book not only for you, but that people will want to read.
So, do you think that being a science journalist helped you becoming a writer of science books?
That's a very interesting question. I've often wondered that. Certainly when I was a journalist, I worked, although I wrote a lot for newspapers, features for newspapers when I was a journalist, but I was a day journalist. I was a science class working on news. Now, news is short productions for radio and television, and you do them mostly on the day. They are reacting to what's going on. So it's literature in a hurry. You have to react quickly, you have to interview, you have to get information fast, and then you have to present it basically in a no-nonsense way to get the information across. And that made me, in terms of storytelling, when I needed to be, straightforward. Because there are times when you're telling the story of, say, of Apollo 11, it's such a wonderful story, you don't want to get in the way. Therefore, you have to tell it in a straightforward manner, without too many digressions or too much waffle. You have to sort of take the story and treat it in an articulate but uncomplicated way. So I brought that with me from news, in the sense that I do that. But having said that, I really enjoy the process of writing a book in treating information in a different way from what I did when I was a news journalist. Because one thing I did when I was at the BBC, I was involved with the startup of the internet, of the BBC News Online section. And this was the first time the BBC had got into internet news.
This is history also.
Yeah, and we didn't know how to do it. We had no clue how to do it. How do you start off with news online? So the way we started it is we started off writing it as though we wrote it for radio. And then we realized that that had to evolve and change, and along with the design of the website and the reach of the website. And that taught me a lot more about the process of writing. But it's all experience. And I think I can say that writing a book is very different, although you take the skills you have with you. It's very different from writing for television or for radio. The length, the structure of the book is everything, because there are lots of science books where people just throw the information up onto the page. This launch, that launch, it went into space for so long and went into this orbit and blah, no, that's okay if you want the information, but if you want to be entertained and informed, then you have to write it in a bit more of a literal way. So I always tell people that if they want to, that writing a science book, the science you should get right anyway. That's a matter of doing your homework. You talk to the right people, you do research. There's no excuse for getting the science wrong. What you have to do is work hard on the writing. And to do that, as well as reading other science books, you have to read good writers. You have to read in science, say Carl Sagan, who is a fabulous writer.
Yes.
And you also have to read, you have to read Hemingway. You have to read Somerset Maugham. You have to read Fitzgerald. You have to read Conrad, because these are writers who are masters of their craft. And although you'll never do what they do, you learn about the use of words and about the tempo and structure of telling a story. You sort of pick up things, I hope. So writing a science book that people want to read actually is not so much about the science. It's about the writing, because people don't have to read your book. If they don't like it, they can stop. They're not forced to buy it. So you have to help them and reward them for doing it. And that's what I find particularly enjoyable about writing such books about the journey to the center of the Earth or Apollo 11. It's how do I make this a good read for somebody who doesn't know anything about it, but also for somebody who might know a bit more. How can I reward them and make them smile, perhaps, or make them angry? I don't know.
Definitely, it's different than writing a literature. Yes, a science book is of course different. On the other hand, I was thinking while you were talking about telling us how you experienced going down on that mine. So you end up putting in this science book your personal experience.
Oh, yes.
And this is very, very credible for people, because you witnessed that, you saw that, you went there. So the scientific information basically you are sending are also, very personal. And I think this is helpful.
Yeah, you are quite right. A good science book, in my view, as a writer, you have to talk to people, you have to go places, and you have to experience things. So if you're going to write about a mining, tunneling into the earth, you go to a mine. If you're writing about Galileo, you go to the Leaning Tower of Pisa, and you experience it, and you write about your reaction, you write about your emotions, how you felt about that, and you put them in the book. Because I don't know about you, but if I read a science book that is unemotional, I find that sometimes a bit hard reading. But if I feel that the writer has some sort of commitment and something more to say than just they were born on this date and they died on that date, then it makes it more of an interesting read, I think. Do you think that?
It's very interesting. The general impression is that science is cold. Of course, it's very exact. Of course, it's very, straightforward. But there is a lot of emotion in science. So
yeah, you're right. You're absolutely right.
You have to feel this, and you have to let people feel this, and then they will cross the barrier, this mental barrier, that science is so rigid and it's so dry and it's so hard to understand. When you write a science book, you don't put formula there. You don't.
You are quite right, Corina. That's absolutely right. For most people, if it's not a textbook, then most people don't want formula, and you've got to find a way to tell the story. Do you do the story with people's personalities? Do you do the story with events? Do you do the story with how you interact with the story, where you go, who you spoke to? Do you deal with rivalries or controversies? Do you deal with discoveries that are made, and how, you've got to, this is the wonderful thing about writing a book, because you have all these ideas and approaches which you can follow: historical, emotional, follow the literature, talk to people. You've got all these ideas, and you could write at the beginning of the book a huge sheet of paper with all these things on it. But at the end of the day, your job as a writer is to turn this into, I don't know, 60, 70, 80,000 words that people read. And they start at one end and they finish at the other. And that is the wonderful process of writing a book, because the thing I find so fascinating is I can do all the research, and I made some big mistakes. The first book I wrote, The Moon, I thought I spent 6 months researching and then 6 months writing. I had a year to do it. But then I realized when I started writing that half the research I'd done I didn't need, and half the research I needed I hadn't done. So I realized you've got to start writing, because the wonderful thing, the thing which still amazes me to this day, is that you sit down with all this research and these ideas and you start writing. Writing is about sitting at your chair, fingers on the keyboard. And if it's nonsense, you still write. You've got to write. People like me, people like you, I suspect, have to write. You've got to do it. But when you start writing and you get in the groove, you end up writing stuff with an approach and a language and a direction you could not possibly have foreseen, that you don't plan. And you end up sometimes writing for long hours, and you stop and you think, where did that come from? I didn't plan to write it that way. I didn't plan to take that direction or use those words, or and you amaze yourself and you think well, that's the way to do it. And you get that not from research, you get that from sitting down and trying to put the words together yourself. And that is the thing which I've never gotten over, and is different for each book, is that the process of writing is exploratory for yourself, and is interesting and tells you something about yourself. And towards the end of the book, it's very complicated and it's a mess, and you've got loads of different lines, but somehow it's by magic. Somehow towards the end in the last few weeks of writing the book, you see the picture, you see the way it's got to go, you see the line you have to draw, and it comes together. And that is just the most amazing feeling. When you finally, that this thing of ideas and treatments and directions and stories and impressions, finally it starts to come together as a book. and you see it as one thing. That is something I've only written a handful of books, but every time that happens, it is magic. And if everybody wants to write a book, try and do it. There's a book in everybody, and try and you'll get a hint of you'll get that feeling. It's wonderful.
It's very encouraging what you are saying, because I always thought that being a writer, you have to be a writer by, how to say, you have to be born to become one day a writer. So you have to have this talent to write books. And I have the feeling that you enjoy a lot writing books. And don't you miss journalism?
I still do a bit of journalism. I comment on things that happen during the day. I do radio and
yeah, but not on the way you were.
No, but not sort of intensively like that. The answer is no. I think we've had enough of journalism. Like amazingly enough, when I was young, I wanted to be an astronomer. That's all I wanted to be.
And you were.
And I were. But after a couple of years of that, I then realized that it wasn't quite as fun as I thought. And there were other things I could have done. And I did them. And to be honest, I think that being on call 24 hours a day to a newsroom which is insatiable, you can have enough of. And fortunately, I left the BBC when I still had time to do other things. It's the tragedy of journalism sometimes, that if you stay in a job like that, you have a great time. But when you leave it, you can sometimes leave it when you've not got time to do anything else.
When you still have energy to do.
That's right, yeah, because I worked for BBC News for 20 years. And if I'd have worked there for 30 years or plus, I think that I wouldn't have been able to write these books. So I'm very pleased that, and the thing is about a book, things about a news item on the television or the radio, sure, it's great, sure, it's heard by a lot of people and appreciated. But the following day, people forget. It's another day, it's another news, and they forget your name. I mean, if anybody thinks they're going to be famous because they're a news reporter or a science correspondent, forget it. Because a week after you leave the job, they forget about you. That is the nature of the news business. But when you've got a book, it's on the shelf, people read it and keep it, and it's something of yours that's in a library somewhere, or somebody sends you an email from the other side of the world saying, hey, I love this book, or I didn't like this book. And you feel it's yours and it's something more permanent.
And you don't feel at all worried about the digital, environment that will replace even the paper books.
That's a big debate, isn't it?
It is.
That I get the impression that books, there was a time, I think about 10 years ago, when I used to speak to publishers and my agent, and she said that everything's going digital. The idea of being able to get a book instantly on your screen, and everybody was thinking that was the way to go. But I think slowly since then, books have made a comeback. And I think people, if there's a book I need to read straight away, I'll buy it online and read it. But if there's a book I want to enjoy, and I want to study, and I want to have a different relationship with, of course I will buy the physical book, because there's nothing like a proper book, which you open, and which you can. It's a different relationship, and I think that about 10 years ago we sort of lost that balance. So I certainly buy as many physical books as I used to. I buy a lot of books on the internet for books which I want to read but don't mean as much as the physical books I buy. You can see,
Yes.
And I've got books in rooms all over the place. Perhaps this is my generation or so, I don't know, but I rather suspect that although people enjoy the convenience of digital books, and they're quick and they're instant. I mean, for instance, who reads Shakespeare on their computer?
Maybe there are people reading, but
Maybe there are.
still.
Who reads
Mhm.
Hemingway on a computer or anything like that? I mean, it just doesn't seem. I wouldn't say it doesn't seem right, but it's not as, to me, it's not as satisfying or as interesting.
But also an encouraging thing is that people are buying science books. Yes, which is again maybe it's the failure of the educational system that led you with the impression that again science is something that cannot be swallowed very, very easily. And coming to this point, so of course you are a scientist basically. You start being.
I was a scientist years ago.
Okay, you start being a scientist, and then you became journalist, science journalist, and then now you are a writer.
Yeah.
Was it helpful for you to be a scientist and then becoming a science journalist?
I've often thought about that. I tell you how I got into journalism. When I was a scientist, I used to write things for news. So I've always wanted to write. I wrote things for New Scientist and for newspapers. And then the BBC radio and telly used to phone me up saying, can we interview you about this, that, and the other? And it was great fun. And often my colleagues were a bit jealous and they didn't like it. And being a junior member of an astronomy department, I certainly felt that resentment. But then the BBC did something very underhand. They offered me a job. And it was the time when a chap called John Burt took over the BBC. And he had the idea that for specialist subjects like science, rather than take a general reporter and say, right, you from now on, you are the science correspondent, learn about science. He would find a scientist or somebody in the field of science or defense or whatever, and say, you've had some experience of journalism, come and learn about journalism, and do it the other way around. So I got into journalism that way, and it was a very interesting experience being at the BBC, coming from the world of science. And so certainly I got the job because of my scientific background, but also because I was sort of media friendly, so to speak. And I've often wondered if you need that to be a science journalist. I don't know the answer to that. I know some science journalists who started off in different fields and are wonderful. I know some of them that aren't. And I know some science journalists who started off in science and are not very good. And I know some who are. So I think it depends very much on the individual person. Certainly, I certainly used to find that when I was at the BBC, if I said I can report science better because I was once a scientist, then those colleagues who reported science who weren't scientists disagreed with me. Those colleagues who were scientists and report scientists agreed with me. So there's an interesting philosophy and culture there. But ultimately, journalism and writing are a practical thing. They're about sitting down and putting the words together. And there are craft skills, there are techniques, and there's experience. And, well, you know, I think everybody has read a book by a scientist which is unreadable. Not all scientists get it.
Yeah, absolutely not. Absolutely not. Yeah.
I mean, I remember interviewing, I used to obviously interview a lot of scientists, and there were really good ones. And that was the really good ones, Rob, were the reason why they got on air a lot and became celebrities. But occasionally, very often, not occasionally, you had to interview a scientist for a particular story who was just darned hard work, you know, and couldn't communicate the subject very effectively. And that's when the skill of the journalist comes in to try and deal with it. But
Here,
communication, being good at communication and being good at science do not always go together.
absolutely, and being a good scientist doesn't mean you can be a good science journalist. Sorry, but this is the proof that we need science journalism to translate, the rough scientific language,
Quite right.
and we need science writers to give us books like this one. Just one or two more questions. There is a question from the audience. I don't know if you see it. So what are 3 things you would like us to remember about Earth that can make us be better inhabitants of it?
Well, that we live on a remarkable planet, but we only live on a part of it. And that most of this planet we do not see, we do not experience. That the world beneath our feet is very different from the world around us, the skin. So our planet is not just the clouds, the oceans, the rivers, the forests. There are most of it is different. We're only here for a short time. The time scales of the changes of the Earth are vast and are great. And it may well be that humanity is only here for a very short time. I hope not, but things may change. The wonderful world we see around us, which is, despite what we're doing, it's still a wonderful world. There have been times in the recent past, when it's been different. 10,000 years ago, Northern Europe was under a kilometre of ice. It would have been very difficult to live then. Great Britain, where I live now, was uninhabitable. And that was only 10,000 years ago. So the Earth can change. It's under no obligation to always be nice for us. But I suppose the third thing is it's just an amazing place. That so many things, well, I've had some scientists say that we are here because there are so many things that have come together. We have the right temperature, we have the right atmosphere, etc. It's not quite that way around. We're not here because of those things. Life has developed into that environment. So that the reason why we are fitted to our environment is because in the past, the Earth was a different place. There was no oxygen in the atmosphere. A lot of the early creatures we have descended from could not survive on the Earth today. We are intimately intertwined with everything that goes on. When you realize that we're here as much because of the core as we are because as the clouds, that gives you a sort of sense of the bigger picture. So I probably haven't answered your question very well, but just go outside and look at volcanoes, and look at a picture of a map of the Earth, and just think, wow, if there are other things like this out there in the universe, what must they be like?
Yeah, we should look more around us.
Yes, I think that. But finally, the last sentence answer was that whatever is else out there in space, other planets with other forms of life, the Earth is wonderful and is significant and has done the universe proud. If we find life, we find other Earths, we find other civilizations, we can hold our head up because our Earth is wonderful and will be just as good as anything else.
There's another question. So who are some of the scientists that made you be enthusiastic about the Earth and the research that was done to uncover its core?
Well, the thing about writing a book like this is, particularly when it's a new type of field, is what I did was I wrote down the 50 top Earth scientists in the world in their various fields. 50. And I then started to talk to most of them. And most people were quite happy to spend an hour or two talking to you. And then you find out that find the people you never thought would be wonderful turn out to be amazing and have fantastic stories. And then you delve into history and you find people like Engi Lehrman. Engi Lehrman came up against the male establishment 100 years ago, the male establishment, which told her she was wrong. But she fought back, and she proved herself to be right, and that the Earth did have a solid core. And she was so inspiring, and she should be far better known. And I was really sad that by the time I realized her worth, I was not able to go and meet her. I think Engi Lehrman, but also that on a strange, strange twist of things, there was a guy who was instrumental in the development of seismographs and these things that measure earthquakes. And his name was Mullard, and he lived in Ireland and in Wales. And I researched him and various other great Victorian earthquake hunters. There's a chap called, there's a wonderful chap in the book who was the Dr. Earthquake of the Victorian age. And he was a wonderful, he had a Japanese wife because he studied in Japan, which is the most earthquake-prone country in the world. But
I'm sorry, you have very nice pictures in the book with them.
He was an amazing chap. I'll tell you a story about him in a second. But I also found a scientist called Mullard. And actually, a bit of research showed he was related to me. There you go. There's Engi Lehrman at the bottom there.
Yeah.
But the Victorian gentleman had an observatory in the Isle of Wight, and he had a very sensitive seismograph, and he noticed that at certain times, he saw tiny earthquakes, and they were periodic. He thought, how can you have periodic earthquakes in the Isle of Wight? And he thought perhaps it's related to the railways. Well, there weren't many railways in the Isle of Wight. Perhaps it's related to the docks or the industry doing something regularly. He couldn't work out what it was. And then, the story's a little risque. And then he found out that once a week, once a month on a Thursday, the butler and the housemaid have their afternoons off on the same day. And this was when the earthquake happened that he was able to detect with his sensitive detector. So it just goes to show that we have very sensitive measurements. And sometimes, information comes up which is makes an interesting story. But I remember going to his the place where his house used to be in the Isle of Wight, and it's demolished. Earthquake Milne, he was called, and he was the Carl Sagan of his day. Opera singers, statesmen, Queen Victoria used to come and tour his mansion to be told of earthquakes. And he was the centre of the British Empire reporting structure of earthquakes. So he amassed an amazing amount of data from the empire. And he really did propel the study of earthquakes and the distribution of seismographs around the world dramatically forward. But when I went, as I say, you've got to go to places. I went to the site of his house, which is demolished. And there's a small plaque there. And I thought, this is sad. This was a major part of science. But in the corner of a field next to a housing estate was a row of Japanese cherry trees. And they were incongruous. They shouldn't have been there. And then I realized that Earthquake Milne's wife was Japanese. He met her when he was studying, as I said, in the most earthquake-prone country in the world, where he learned about earthquakes. And I thought this was wonderful. You wouldn't know why those trees were there unless you realized that Tone, his wife, had planted them in the garden, and they were still there. It's the only thing that was left. And life's like that. Sometimes
Yeah, it's
These
sad.
things make wonderful stories.
Yeah. You have in your book, and the listeners should know this, the first seismogram.
Yeah.
That was recorded in April 9, 1889 in Potsdam, Germany.
Yeah. There it is. Yes, that little thing there. And the thing is that I think I'm right in saying that earthquake was from China. And they then realized, not that long ago, 150 years ago, that you could have a seismograph, a very sensitive seismograph in Germany, and you could pick up an earthquake on the other side of the world.
Yeah, that's true.
That is amazing. And also, if you have, as Earthquake Milne found out and others found out, and Len Guillermin in particular, if you have seismographs all around the world, when an earthquake goes off, they record different things. The signal arrives at each seismograph at a different time, and the shape of the signal is different because sometimes the sound waves go through the crust, sometimes they go into the earth and out again. And by piecing these things together, you can X-ray the earth. And there's an amazing route which has probed the very center of the earth. There are earthquakes which go off in the South Sandwich Islands occasionally. And there are earthquake detectors on the other side of the earth. And they're able to pick up the faint shock wave that's traveled right down into the earth, through the core of the earth, and then back out. And therefore they provide unique information about what's right at the very center. And there is to my amazement, I found out I was writing this book that the World Center for Earthquake Data is actually about half an hour's drive away from where I live. And I never realized this. It's in a warehouse next to a station near the city of Reading. And I went into this place and there are stacks and stacks of old books and ledgers and documents of earthquakes that have been reported from all over the world that have yet to be digitized and analyzed. And they are putting together a unique portrait of our planet, of the earthquakes which go on, because there are earthquakes every day, all the time somewhere.
Yes, and earthquakes are some of the most mysterious phenomenon.
We still don't know
very
much about them.
Yeah.
And the interesting thing is, you mentioned the internet. You can watch them take place real time. Go to the United States Geological Survey's website.
Yeah.
You see these earthquakes take place and reports about where they are and how deep they are and what type of earthquake they are. And you see it happening in front of your face. It's wonderful.
Yeah, this is the technology advancement. And speaking about the technology, and we'll end soon.
Sure.
Don't you think that soon we will be able to travel to reach the core of the Earth using virtual reality?
That's a very good question. I suspect that virtual reality is just in its infancy, and that its ability to provide scientific experiences is yet to be realized. It may well be that you could swim through the outer core in a submarine, or land on the surface of the solid core of the Earth, or traverse underneath the roof of the mantle from the core, or even go and sail the hydrocarbon seas of the moon of Saturn, or drive around Mars with virtual reality. I don't think when we go back to the moon in a few years' time, if somebody was to make a virtual reality program of the real view of what it's like to stand on the moon, and you put your helmet on or your goggles, and that is it, you're on the moon, they would make a fortune. You're quite right.
Good idea.
Somebody would do that for the Earth. Imagine being able to fly through the rocks from the surface to the core and experience the changes. Oh, somebody do it, please.
Yeah, maybe we'll see it. Maybe next generations will see it. Anyway, it's very interesting. So we are going deep into space to see. Maybe we can end up learning something about the core of the Earth, looking in space at something. Who knows what how to say, science development will advancement will bring us the technology. You never know.
You never know. Of course,
you never know.
Studying the Earth, you understand more about it by studying Mars, Venus. These planets have cores and crusts, but they're different. So, the Earth is wonderful, but you also get a perspective on other planets. When you study the Earth.
Yeah. But you also go deep down in the Earth to study neutrinos, to try to understand what happened. Yes.
Yes.
Up there.
There are in caverns. There are these mysterious particles that traverse the universe, and they come from strange places. They come from exploded stars and where else. But you need quiet, and you need a certain amount of a certain type of detector to pick them up, and you can do that well from caverns. In fact, there are caverns which are looking for this mysterious dark matter.
Yeah,
which is supposed to make up the universe. You can't measure it with a detector on the surface of the Earth because there's just too much going on. And yet there is these wonderful caverns underneath the Alps where it's quiet and nothing changes, and the background radiation is low. And they haven't found them yet, but who knows? It's certainly strange to be 3,000 feet under the ground, because the taste and smell of salt was amazing. There's dust on the atmosphere, and you're in this tunnel which has been dug out, and the tunnels went on for miles. It's a salt mine. It went on for miles under the ocean, and yet you've got your helmet on and your light, and that's all you see, the pool of light in front of you, and it's hot and it's humid. It's like being for the rest of the universe, the rest of the Earth doesn't exist. It's so different from the plants and the oceans and the clouds above your head. That was the most fascinating experience. And I thought that there are people who live and work in this region.
Yes,
and
actually.
They have a very different, and so I then went back and wrote about the people in Jules Vernes' Journey to the Centre of the Earth and how they experienced darkness. And I sort of understood what they were on about, I hope.
Speaking about Jules Verne and about his book, so it's very interesting, and this is fascinating in your book, that you are going back and forth. You are using, how to say, Jules Verne's travel as a kind of reference. You go there, you come back, you go up in the space.
You're quite right, because people don't realize it's about Jules Verne's Journey to the Centre of the Earth. It's a wonderful novel. It's totally fictitious in the sense that he finds dinosaurs and ancient humans living down there. But at the heart of the book is a debate between the professor and his nephew. And the debate is not between them. They were saying, well, look what we can see. But the professor's saying to the nephew, yes, but where is the evidence? What is this? And you realize that the book is very clever in the sense that it's of its time, but it's essentially a debate between the professor and his son, the debate between old-fashioned natural philosophy and modern science that demands evidence.
Proofs, yes, evidence. Science based on evidence.
And that is that. Once you see that, the book makes sense. It's wonderful.
Wonderful. Thank you very much, so much, David Whitehouse, for this absolutely fascinating talk.
Thank you.
Congratulations for this book, and we are waiting for the next one. What do you have?
Well, I wrote Apollo 11, and then I wrote a sequel to Apollo 11 called Space 2069, which was where we will be in space 100 years after 1969 landing. But actually, perhaps for next year, I've just finished the manuscript of a book about aliens.
Oh, this is a fascinating subject. And actually, now is the last question because we have it here. What do you think of intelligent life on Earth and the possibility of being discovered by others?
You know, that's at the heart of my new book about aliens. Who knows if there are aliens out there? But it has been said that we have alerted the universe to us because of our radiation of television and radio. Actually, in the book, I find that that's not as bad as people thought, and that the signals we put out into space are not easily detectable amongst the nearest stars. So we haven't yet quite sort of stood up in the cosmos and said, hello, we're over here, to anybody who might be out there.
So yet gives us a little bit of hope.
Gives us a bit of time and hope to prepare ourselves for whenever we might find somebody else out there.
Do you think we'll find somebody else?
Who knows? I mean, it could happen tomorrow. It might not happen for hundreds of years or at all.
Or never, yes.
Yeah, either way, it'll tell us something important. But, I mean, I joked that my book about aliens should be called Everything We Know About Aliens, and it would consist of 250 pages, every one of them blank. Because this is all speculation. But yeah. I rather think that we are not. There are others out there who are intelligent. But the thing is, they won't be like us. There will be an intelligence which is different from us in the same way that dolphins are different from us. And that they will have a different history, a different art, a different culture, different senses, a different way of seeing. And that is wonderful. And I say in the book, we will not truly understand ourselves or the universe unless we have somebody else to talk to about it and say, how do you see it? What do you think? That's the good side of it. It may well be that they're nasty and want to wipe us out. We do not know.
Hope to find answers maybe during our lifetime, but yes. I'm not so sure. Looking forward to read your book about aliens.
Thank you.
Thank you very much for this again for this talk. And thank you everybody for watching us. The book is in the bookstore. Thank you very much, Editurii Humanitas, for hosting this meeting with David Whitehouse. All the best to you, and like I said, all the best, and looking forward to see your next book.
Nice to meet you, and thank you very much.
Thank you very much again. Bye bye, everybody.